All right, welcome everybody. This is Jerry Ola, product manager here at Akahau. Good morning, good afternoon, depending on where you are in the world. We've got another great session here talking about improving and reducing airtime utilization. So yeah, thank you for joining. This is kind of a part two to our airtime utilization webinar we did a few weeks back. Before we get started, a couple housekeeping items. You're in a listen only mode, so your lines are muted, but we do have a question Q&A pane that you can locate there and submit your questions, as well as utilize the chat functionality. We'll collect those questions throughout the webinar here and do our best to answer those at the end. And yeah, we've got our subject matter expert on this topic here, Mr. Joel Crane, is going to be presenting on this very important topic about airtime utilization and how to optimize that. So yeah, me and Joel kind of tag team this throughout and provide you with some demos. Joel, turning it over to you.
Sure. And wait, you said that I'm the subject matter expert? I thought you were the subject matter expert and I was just here to, okay. All right. Well, I guess we'll figure it out as we go. We'll just wing it.
I didn't get that memo, so I figured you were going to tackle this difficult topic.
Oh, okay. All right. Well, tell you what, let's just tag team it and we should be good to go. We should be all right.
What's the worst that can happen, right?
Yeah, exactly. Well, PowerPoint can crash. We know that. So, well, awesome. Thanks for the introduction, Jerry. So yeah, just a couple things I'd add to kind of the housekeeping items. Feel free to use that Q&A tool that's built into Zoom to ask your questions. And if you'd like to just kind of make a comment or, have some conversation with the other viewers, feel free to use the chat function to do that. Blow up the chat. We enjoy watching everybody talk in there. But if you do have a question for us, go ahead and stick it in the Q&A tool specifically, and that way we can be sure to get to it. If you put it in the chat, then we might miss it. So yeah, go ahead and use those tools as much as you want. So, well, hey, thanks for joining us for this webinar today. Like Jerry said, my name's Joel. I'm the technical training manager here at Ekahau. Jerry is one of our product managers here at Ekahau, and we're really excited to present on this topic to you once again. So let's talk about the agenda really quick, just so that you know what to expect throughout the course of this webinar. Previously, we talked about airtime utilization, basically what it is. I don't know, Jerry, do you remember some of the other specifics of things that we talked about in that webinar?
Oh man, I blocked that webinar out. That was, it was a while ago. No, we talked about, actually probably one of the things that stands out to me is just, what is airtime utilization, and then comparing that to some of the other things that, that get bundled in with that, right? We've got spectrum utilization, channel utilization, duty cycle. So there's a lot of things to get confusing and kind of jumbled into that kind of utilization pile. So we tried to really kind of hash that out and figure out what's what there, and what makes up airtime utilization, what causes airtime utilization.
Yeah, absolutely. Yeah, we covered, what it is, what causes it, how airtime utilization is different, how, I don't know, there's a lot of different terms kind of in this whole utilization camp here. And I think that even might be a webinar in and of itself. So we might have to think about that for like a future topic of talking about how airtime is different than utilization, and how utilization is possibly different from duty cycle and all that stuff. I'd really like to talk about that some more. But what we'll do is we'll take kind of a quick review of what is airtime utilization and what causes it. And then after that, we'll jump into talking about how to improve and reduce it. So I think basically the plan here is I'll talk to each of these points a little bit. And then once we get into kind of that how-to section, Jerry's got some great demos lined up here where he's just going to basically show you, I mean, real world hands-on exactly how to do this. I think we counted our slides. I think we have like less than like 7 slides of actual content here. Most of it is in live demo. So the slides are just here to support the live demo, which personally is the way that I like it. I like it that way. And I think Jerry does too. So let's talk about, and then we'll do Q&A at the end, of course. So, feel free to put those questions in the Q&A tool. And we are looking forward to tackling those at the end. Last time we had way more questions than we could answer. We love that. It's a lot of fun to answer your questions. So please feel free to put those in as we go throughout the webinar. So the first thing I want to do is let's just take a quick recap. of what we talked about last time. And one of those things is, what is airtime utilization? Well, let's boil it down really quick. We'll just take about 60 seconds to talk about this. Remember that Wi-Fi is half duplex. Now, Ethernet is full duplex, usually, unless you've got a bad cable, which means we can send traffic in two directions at the same time on the cable. Wi-Fi is completely different, though. It's half duplex, which ultimately means that only one thing can talk on a channel at a time. And if only one thing can talk on a channel at a time, that means that there is a limited amount of time available on that channel. Basically, whenever something transmits, that causes airtime utilization. That utilizes the channel. And you get to a point where eventually the channel is out of time. There's no additional time left on the channel. Think of it kind of like a dinner table conversation. If you have a couple friends over, something like that, and you have dinner, maybe there's only 3 or 4 of you at a dinner table, there's plenty of time for everyone to get on the air and say what they want to say as part of that conversation. Whereas, if you go to, maybe you have a family reunion or something like that, or you go over to the in-laws for dinner, and all the other, all of your in-laws are there, and they've brought all their kids, and there's just a bunch of people in one place, or just a big table with a lot of people around it. It gets really difficult to get a word in because there's not a whole lot of there's no airtime left. And so eventually we will consume the amount of time that is available on the channel. We will reach the channel's capacity when airtime utilization gets too high. So Jerry, I think last time, if I remember correctly, I think you and I kind of agreed that for general kind of mixed general data applications, about 50% airtime utilization is about, or no, I'm sorry, I got that backwards. For voice over Wi-Fi, if I remember correctly, we said that about 50% is the maximum that we can really handle on a channel when we're doing voice over Wi-Fi applications. And then I think we said 70% is the maximum for general data usage. Is that correct? Is that what we said?
Yeah, and that actually aligns with what's in Ekahau. So when we get into Ekahau, we'll kind of show where those thresholds are defined. And those are defined based on your usage, your applications that you define in the software. It adjusts those thresholds automatically based on, if you're specifying you need to support voice applications or if it's just data. But yeah, that aligns with what's in ESS as well.
Yeah. I think basically the reason behind this is that, when we're just using general data applications, if you're just browsing the internet, if your client device has to wait a little bit longer for the access point to get an opportunity to transmit, like, let's say, an image back to your web browser, it's okay if we have to wait a few milliseconds longer. Whereas with a voice application, we need to keep a little bit more time available on the channel for devices to be able to communicate quickly and not have to wait for a turn to talk. Because things like voice over Wi-Fi or voice over IP, like Jerry and I are using right now to talk to you, those packets have to be delivered in an extremely consistent and timely manner. And so we have to keep some more margin there, basically, to allow devices opportunities to talk. And so
yeah, I think one other way to kind of look at that too is you look at it from the inverse side of, if the channel is greater than 50% utilization, that means over 50% of the time, either the AP or the client has to defer its communication, right? There's contention there. And then obviously greater, further yet, 70, 80% of the utilization means that there's that much more time that the stations have to back off and defer their communication, which is why real-time applications like voice over Wi-Fi are not going to work properly in that type of situation with that utilization, right?
Yeah, I would absolutely agree. So the amount of acceptable airtime utilization depends on the applications that you're using.
Yep.
Very much, doesn't it?
And I think the other key thing to point out there is, often we think of, we're only pushing 70, 80% of this channel's utilization. We still have 20%. Why are clients complaining about the Wi-Fi being slow, or, why is the Wi-Fi not working properly? Why are clients having a bad experience when, the utilization is only at 70 or 80%? And really, in reality, because of the way the backup mechanisms and carrier sense and everything works on the on Wi-Fi, you should never see of actual Wi-Fi energy, Wi-Fi traffic utilization greater than 80%, right? Because of all those other mechanisms built into there.
So you'd say maybe, so I typically say 70, you're thinking about
Well,
80%
no,
is
why I
probably.
say 80 is because if you do see a channel greater than 80% utilized, that's a good indication that there's something going on there beyond Wi-Fi. I'm just saying the maximum that Wi-Fi can utilize a channel for is 80%. If there's more than 80% utilization, that's a good red flag that there's some other energy here on this channel that's occupying more than just the Wi-Fi.
That is an awesome tip. I really like that. That's pretty cool. So yeah, okay. So what you're saying is that, Wi-Fi will use up to about 70%. That's where we kind of start hitting the limitations of the protocol and how airtime arbitration stuff, all that works. If you see 90 or 100% utilization on a channel, though, that's an indication that maybe you've got some kind of non-Wi-Fi device causing that, such as I don't know, such as like a wireless video camera or something like that, some kind of analog device.
Yeah.
Cool. Right on. Awesome. So the next thing we wanted to cover really quickly is just kind of part of this recap is, whoops, I clicked one too many times, is what causes airtime utilization. So lots of different things can cause airtime utilization. And you see that airtime utilization isn't necessarily a bad thing. It's just that we have to keep an eye on it. We have to understand it. We have to know what it means. And in some cases, we do need to reduce it. If we see that it gets too high, that means that, there's not going to be opportunities for devices to transmit, and we're going to have a bad user experience on the network. So what causes it? Well, one thing is just, application usage. Whenever you download a web page to your web browser, or whenever you transmit some data or something like that, then that's an indication that's just an application using that channel. Now, applications causing airtime utilization is totally fine, but we need to manage it. We need to know where the limits are, and we need to, in some cases, understand how we can reduce it to fit more capacity on a channel or on a network. Any thoughts on that, Jerry, before we move on to the next one?
No, I think you got it.
Sweet. Nailed it. Next one is slow data rates. Now, remember, like I said a moment ago, Wi-Fi is half duplex. Only one thing can transmit on a channel at a time. When you have a device that uses a slower data rate, like maybe it's kind of far away from the access point, and so it's had to slow down to a legacy data rate to make sure the access point can hear it, that's going to consume more time on the channel. Think of it kind of like this, a device that's transmitting at 54 megabits per second versus a device that's transmitting at 1 megabit per second. That device transmitting at 1 megabit per second is going to take 54 times longer, approximately, to transmit the same amount of data. So slow data rates will consume more time on the channel. Another one that can get you is retransmissions. Wi-Fi is very similar to TCP/IP in that we will transmit a piece of data, and then the device on the other end will transmit an acknowledgement back. If we don't hear that acknowledgement back, then the device that transmitted it originally will go, okay, well, I never heard an acknowledgement, and it will attempt to retransmit that data frame again. That takes more time. And so if we can avoid retransmissions and just kind of like get the data delivered correctly the first time, that's going to help out. That's going to improve airtime utilization. Another one is just more devices. The more devices you have on a channel, the more airtime is going to be used. And so, if you've got 25 users on a channel versus 50 users on a channel, that's going to consume more airtime. And so we've got to think about, okay, well, how can we chop up our coverage cells, make them smaller, keep the same channel coverage cells from hearing each other, and things like that. And we can reduce the amount of devices inside each coverage cell. And James says more. It's like, yes, James, I did spell it like that. So I'm glad somebody noticed.
You gotta say it properly. More devices.
More devices.
If you're gonna spell it like that, you gotta say it. Right?
You gotta say it. Yeah, I guess that was my mistake right there. More devices. Another one is, non-Wi-Fi interference also causes utilization. Non-Wi-Fi devices that operate in the same frequency space, whether that's 2.4 or 5 gigahertz, they also need to talk. And the thing that is pretty lame about non-Wi-Fi, well, it's not lame, it's just how it is that non-Wi-Fi devices, they don't have the same politeness mechanisms that Wi-Fi devices do. Wi-Fi, if it sees something on a channel, it will just continually back off and wait for an opportunity to talk. An analog wireless video camera, it doesn't care. It just starts talking. And those devices will also cause utilization because they're transmitting in the spectrum, and so they cause that. So I guess the question that remains, and the question that we are going to attempt to answer in this webinar, is how do you reduce and improve airtime utilization? Here's what we're going to do. Jerry and I we've basically identified about 5 different ways that you can improve, or you can reduce or improve an airtime utilization problem. So I will present the problem, and then I'm going to kick it over to Jerry, and he will demonstrate that live in Ekahau. And so you can see exactly how that works, how to do that. So the first one is to remove non-Wi-Fi interference. So Jerry, tell us, how can we detect, identify, locate, and ultimately remove non-Wi-Fi interference?
Well, how about better than tell you? I show you.
Oh, great idea. Let's do it.
All right. Let me know if you can see my screen okay here.
Yep, got it. You're good to go.
All right, so I've got a project file pulled up here. Let me actually bring down the real-time frequency monitor here so we can look at the survey data here. So this is a small survey we completed recently. I think actually we even kind of demoed this one a little bit in the last webinar, but we'll look at it through a different set of kind of visualizations here, because we're talking about reducing utilization, or specifically non-Wi-Fi interference in utilization. So right now we're looking at the default view on this project file, which is signal strength. Let me actually collapse this down so we can make this map a little bit bigger here. And let's switch over to, since we're talking about utilization here, let's look at spectrum utilization. So this is going to look at the measured spectrum utilization based on the spectrum analyzer in the Sidekick, the Ekahau Sidekick we used to do the survey. Last session, I think we looked at the spectrum channel power, which is another way that we can look at spectrum data, but this is looking at specifically based on utilization of spectrum and where we saw high utilization. So you can see the majority of the areas in this, if I pull up the visualization statistics, things are, green and nice, pretty low utilization. Right now we're looking at both 2.4 and 5 gigahertz. I can flip that to just show 5 gigahertz, and you can see nothing really changed too much when we isolate just to the 5 gigahertz band. So yeah, 0 to 10% utilization in over half of the areas that we surveyed. A few higher utilization areas, and then we see this kind of little bump up here. Remember we talked about those percentages around 50% or greater, and you can see areas that we were seeing 50% or higher on the map here. So we may want to investigate those areas, especially if we're doing a voice over Wi-Fi deployment. And I always like to do kind of a readiness survey if I'm going to be deploying voice over Wi-Fi, and look at what does the spectrum look like. Is it going to support a voice over Wi-Fi solution? Well, the majority of this, survey does reveal that we have low utilization in most areas. And again, this is just a snapshot in time, so kind of take that for what it's worth. But if you have a constant transmitter like we did in this environment, this could certainly cause some issues. So here we can see in this particular area where we saw the highest utilization, we're seeing about 55% utilization. So not terrible, and the good news is that it's really only one channel that's being impacted. So that's another thing to keep in mind, is even though you could see, continually 60, 70% utilization maybe on a specific channel or a subset of channels, that doesn't mean that, we can't do voice over Wi-Fi here, right? We just need to know what channels are being impacted and be able to design around that, or, potentially remove that interfering source, or, put APs further away from that interferer to make sure that those aren't going to have an impact or have less of an impact on those types of applications. So yeah, don't take this as a showstopper if you do find these kind of things in the environment. This just provides us a lot of insight to how to design around this potentially. So here we can see channel 149 is being impacted. I could stop there and we could just say, all right, we're just going to stay away from channel 149 because we saw high utilization in that area of the building. But if we want to investigate that further, maybe we want to try and figure out where the source of that interference is coming from, we could dive into that. So I could click along my survey path here in my survey inspector, and we can get more details about what's happening. And here we can see on channel 149 what that looks like on the spectrum when I was kind of outside of this room, that we saw that high energy or high utilization on that channel. And as we move further along the survey path, we can see how that energy gets stronger, higher dB value there on there. The energy level is getting higher, and also the utilization with that is getting higher. So if I go to the channels view here, we can see, actually right now we're seeing on channel 149, 76% utilization rate at this point on the survey path. So we can see, when we're kind of standing right on top of that here, let's see, where was our utilization the highest? Yeah, right about here, 76% utilization. We can zoom in on that, get a better idea of that signature potentially as well.
Now, Jerry, I have a question for you. Since you're the, since you're the product owner and I'm the technical trainer, I should probably know the answer to this, but I don't, so I'm going to ask it right now. The color scale in the density view, do you remember what does that kind of red or black color mean as far as utilization goes? Where's that threshold where it turns red or black?
Yeah, so this is a percentage scale. That is something that we're actually looking at adding into the tool, is having a scale here, just like you do on your heat maps, right? So similar to what we're seeing here, right? So you've got green to red. That's essentially the same kind of thing that we're seeing on this view here as well, except for now black is also beyond red, right? So it goes from green, yellow, orange, red, and then black. That's meaning how much time it's being measured at that level. And the more it sees it at that power level, the higher the density. And that ties in with this duration value as well. So we're showing right now, this is over a 5-second duration. And that's what those colors are representing. So if we bring this to something like 30 seconds, that's going to show more further along the survey path, as well as beyond or behind the survey path here over 30 seconds. What did that energy look like? And now we can see, it's much lower, right? And now we can see how the utilization number changed as well. So all of that is impacted based on the duration. If we lower this all the way down to 1, we see the opposite, right? So over this 1-second period of time, when we were standing at this particular spot, we were seeing actually 91% spectrum utilization. So the good news is as we move away from this interfere, it drops off drastically, right? So the energy level isn't strong enough. You can see actually right here, even though we're very close to it, negative 60 dB is what we're kind of measuring that at. And you can see as we move away, it drops pretty quickly.
So the duration value is essentially, it gives us a larger time span, and that color is averaged out over that time span.
Yeah.
Cool. And then the spectrum utilization column over on the right-hand side, which currently says 91%, that is the average utilization across that entire 20 megahertz Wi-Fi channel, correct?
Yes. Yeah. So that's looking at the utilization across that Wi-Fi channel and then averaging it out. Basically, how often is this channel being seen as occupied or utilized, right? So 91% of the time, this channel is busy to the point where, less than 10% of the time, a client in this area or an AP in this area would have the opportunity to transmit.
Got it. Cool. So do you want to go ahead and move on to the next point, or do you have anything else to talk about here?
Well, I think, we can move on to the next point unless you see any questions or comments that are worth talking about at this stage.
No questions have come in yet. So I think that, I think we can go ahead and keep moving on here. So, actually, you know what? Brian has a question here. How measurable is interference from microwave ovens, cordless headsets, and other sources of non-Wi-Fi? I think it's a pretty good question. Maybe we should talk about non-Wi-Fi devices for a second.
Yeah, absolutely. I actually have a non-Wi-Fi little video transmitter here that operates in the 5 gigahertz band. So I switched over to the live mode, and this would be the same whether it's a microwave oven or anything like that. But let's go ahead and just plug this in, and I'll plug it in now. And you should be able to pretty quickly see how quickly that shows up on the spectrum here, right? So this is a video transmitter, not Wi-Fi, but wireless, using the 5 gigahertz frequency.
So this is a non-Wi-Fi device, and I couldn't help but notice that it parked itself right next to your 20 megahertz AP there, and also right in the middle of your 80 megahertz network that's hanging out there.
Yep. And you can see the utilization. It's not using 100% of the channel or anything. This is over 5 seconds. If we lower this down to 1 second, we can see that update even that much faster. But yeah, you can see about 50% utilization. So this thing's transmitting quite a few frames. Wireless video transmitter, it's transmitting. I think this is video only. I don't think this thing has audio on it, but you can see that video transmitting, it's 50% of the time. So that's its frames that it's transmitting out.
Yeah. A little observation that I made is that 80 megahertz, that 80 megahertz one, I see it's at about neg 40 dBm. So I'd assume that's yours, right?
Yes. Yep.
Yeah. So do you know what primary channel that's using? Which of those 20s is the primary? You just happen to know off the top of your head?
I believe it's
Ooh, it looks like
132, but yeah.
132, yeah.
Yep.
So an interesting thing that I noticed is that even though that camera parked itself right on channel 136, your AP is actually beaconing on channel 132. And so we continued to see that network was there. So it didn't effectively jam it didn't jam channel 132 where the AP actually exists. It just jammed one of its 20 megahertz channels. So just kind of fun. I've never seen that happen before just because I'd never had it set up that way.
Yep.
But pretty cool. All right. Awesome. Yeah. Great question, Brian. Thanks for bringing that up. Cause I think it's kind of fun to go check out some sources of non-Wi-Fi interference. So thanks for that. Cool. So let's go ahead and take a look at our next one here. Let's talk about another way you can improve airtime utilization, which is to lower the number of SSIDs. Jerry, how can we improve airtime utilization by lowering the number of SSIDs? What does that do, and how can that help us?
Yeah, good question. So I set up a little demo project file here that we can work together as a group here, and let's see. We'll kind of pull the audience to see if we can come up with some ideas of how we can improve this utilization. So let me get my screen shared again here.
We're getting really good at this screen sharing, passing back and forth thing.
Oh yeah, super smooth.
Seamless.
All right. All right, so here's my awesome design that I came up with, and yeah, kind of pull the audience here. What do you guys think of this design? Do you guys see any, do you have any tips for me, any recommendations on how I might be able to improve this design, specifically thinking of it from an airtime standpoint? Let me actually turn off the areas here to make it a little easier to see the configuration of these APs as well.
Yeah, use the chat function there. And Andrew says more hallway APs.
I like it. Nice.
All right, where is the dismiss button for Andrew here? Let me see if I can. No, I'm just kidding. More hallway
APs in it. All right.
Brad says more APs on the edge. Bruce says there's lots of 80 megahertz wide channels in the 5 gigahertz band. Yeah.
So let's flip over to airtime utilization. So right now we're looking at signal strength, and honestly, looking at signal strength, this doesn't look like too bad of a design, right? If I was just purely looking at signal strength and coverage, I've got a few corner spots that, are kind of grayed out that show that we don't have great coverage in there, but really overall, this doesn't look like a terrible design when we just look at it from signal strength and from coverage.
And it's all green, and green means good, right?
Exactly.
Yeah.
Exactly. So let's flip over to airtime utilization. And yeah, some people are already pointing out some good things about channel configuration. You can see, I try to kind of go with like a default out of box configuration as far as the APs and the network is configured, right? And this is a very common scenario that I do see in the real world is, when there's no real design and engineering to the network and we just take this stuff out of the box and we plug it in, this is honestly a lot of times what we end up with. It's kind of optimized for this kind of more marketing, like, drag race throughput per AP and not for the overall environment. So let's look at that. So if we look at project and network configuration, well, first, here's my, health of the network from an airtime utilization standpoint. We look at visualization statistics and we have a drastically different story than when we looked at signal strength, right? So we're looking at, it says 70% or greater, 100% of the area was seen at greater than 70%. So yeah, what can we do to optimize that? So if we go to network configuration, there's some things we can maybe start with here. So we look at things like data rates. We look at number of SSIDs. What was the thing on our list first? Was it around others?
There are a ton of really great ones in here from Chris and Joel and Jim and Bruce and Brad and I'll say even Andrew too, because
From our
Sorry.
slide, though, what was the first bullet point? Was it number of SSIDs?
Oh, yeah. So right now we're talking about how many virtual SSIDs, I think, is where we left off when we jumped into the demo.
Which is going to tie into our MAC frame types, right? So if we look at the bottom of this tooltip here, we can see a percentage breakdown of what is chewing up our management traffic, our data, our control traffic. And look at this right now where I've got my mouse hovered here, the highest percent airtime being consumed is just management traffic, not even our data. So management traffic is chewing up almost 40% of our airtime right off the bat. And management traffic, ties in with number of SSIDs, right? So let's go ahead and look at our network configuration again. And you can see here, I've got on my 2.4 radio 7 SSIDs that we're simulating being deployed. And on the 5 gigahertz, 8 SSIDs. What's your thoughts there, Joel? What's a good best practice maybe that you've utilized?
I would say 4 SSIDs or less, preferably 2. Bruce says 1 to 3, and I would completely agree.
Yep. Yeah, I would agree with that as well. 3 is usually always kind of the, in a dense, enterprise environment, you're probably not going to be able to get away with 1. If you can, awesome. Less is more. But yeah, because of different, guest networks and, production networks and different VLANs and all these kind of things, often you're going to need to have more than 1 SSID. But yeah, any way we can get these SSIDs down, maybe you can do 2 on 2.4 and 3 on 5, something like that, by turning off like the guest on, or turning off your production on like the 2.4, for example. But let's actually do that. Let's put 2 on our 2.4 radios and 3 SSIDs on our 5. And then let's take a look again. I think I had my mouse right around this area here. And let's just look at that same area and see if we notice any difference here. So yeah, there we go. At least we've started to improve things, right? So now our data airtime, still using up 100% of the airtime, but now a lot more of it is going out as data instead of the management traffic consuming the majority of our airtime. So that one little tweak to our network of reducing the number of SSIDs just gave us another significant bump in our airtime for our clients to actually transmit on. What's the next thing that was pointed out here, or do we want to go back to our bullet points?
Oh yeah, sure. So the next thing that we can do to improve airtime utilization in this environment would be to prune off slower data rates. And so I don't know, Jared, you want me to speak for a second about why that can improve airtime utilization before you demo it?
Yeah, that'd be great.
Okay, cool. So like we touched on earlier, the slower devices are when they transmit, basically the more time they consume on the channel. One thing that I really love about Ekahau's capacity planner is it takes into account, what kind of data rates we're going to be able to hit. So there's a couple of facets here to think about. One of those is think about what your device's capabilities are. Like for example, if I look at my Android phone right now, if I remember correctly, it's going to hit around, I think around 150 megabits per second is the maximum achievable data rate that's going to hit, because it's simply a one-by-one, a single spatial stream device. And so it doesn't have, tons of capability for tons of throughput. If you took that same device and stuck it on a 20 megahertz channel, well, then you're talking about 72, 75 megabits per second is the maximum achievable data rate that you're going to be able to hit. Whereas my MacBook Pro with its swanky, super fast, super good 3x3 adapter, right now we're hitting at about 360 megabits per second. Connected to a 2 spatial stream AP with a 40 megahertz channel. So think about your device capabilities. What kind of, I don't know why my slides are going backwards. I don't know what I did to cause that to happen, but think about the capabilities of the devices, and also think about what data rates you were allowing devices to ratchet down to. So if you've got a device that's really far away from your AP, and it's got really low signal, a really low signal to noise ratio, it's going to have to slow down and use a slower data rate. The same is true for legacy devices as well. If you've got an 802.11b device kicking around in your network somewhere, like you've got somebody really stubborn on your network that's still got like a Palm Trio or something like that, that device is going to transmit very slowly. So one way that we can fix this is to prune off slower data rates. Basically, we could start dropping legacy data rates. Like maybe we could get rid of 802.11b and 802.11 prime data rates, like 1 to 5.5 and 11 megabits per second, in a very, very dense environment where we need to make everything talk really, really fast. Then maybe we need to prune off everything below 24 megabits per second. So, hey, if you can't maintain 24 megabits per second or better, you're out. And so, Jerry, want to go ahead and demo to that a little bit?
Yeah, and we can define some of that, what you're talking about as well, Joel, around the device capabilities in Ekahau as well. Under the device profiles, you can actually create your own custom device profiles, specify what PHY type that device is capable of using, and then, yeah, what's the max supported bandwidth, as well as the MIMO chains that it can do as well. Is it a 1x1 device or a 2x2? We can define those, and that will factor into the airtime as well.
Do you want to plug my my Android phone in there? It's a Nokia 6.1. I don't know if you're looking for, Joel's phone, Joel's Android. And it's 802.11n only, surprisingly.
Oh, wow.
Yeah, I know.
Dual,
it is dual
at
band.
least?
Yep,
Okay.
it's dual band. Yep. It does support 40 megahertz channels, but it is a single spatial stream.
Awesome. That's a sweet, sweet device you got there.
Budget Android phone.
We're trying to improve airtime utilization here, Joel, not make it worse.
And then Joel shows up and ruins everything.
Yeah. All right. So let's add Joel's, let me turn the areas back on here, and we'll edit the, let's say Joel's going to be hanging out in this cafeteria area here. He doesn't really do a lot of work, so he's just sitting in the cafeteria area munching on stuff, and we're going to put Joel's Android in there, and he's just got one device, so at least we only have one wrecking things.
Maybe because I don't have an iPhone, you guys lock me in there and don't let me come out, and so that's, you can guarantee that my client's going to stay in that room.
How much, what kind of SLA do you need?
You know what, I would really like to, I don't know, could you build out a custom profile for me, actually?
Oh man, wow.
You really,
your own.
I do. I have very specific requirements.
All right.
And so what I need to do is do some Dropbox uploads. Oh yeah, Joel's usage, perfect. I need to do some Dropbox uploads, and I also need to stream Spotify. That's the other thing I need to do.
Premium?
No. I am way too cheap for that. Definitely the free one. So, or I guess if it's hard to find, then yeah, just use the premium one.
No, you're getting some junk Spotify. You're getting like low quality audio here. We'll do let's see,
I could have sworn there was one in there. What happened to it? There was a
Spotify.
Yeah, it's totally in there. I thought
this might be an older project file. Wait,
okay.
Here we go. Found it.
Boom.
Got it. You got your not so great Spotify. All right.
Nice.
Is that good, or you need another usage? Just
I'm happy.
All right. Cool. So there's Joel's usage, his device. We're getting real specific here on our requirements here on utilization, but we need to make sure that Spotify works for Joel. So here we go. And now we can see under there we've got Joel's Android using 1% of the airtime. He's not going to probably have a great user experience, given that we're 100% utilized here. So there's going to be a lot of contention on the medium there. Well, let's kind of take things to the next level as far as, we talked about those data requirements. So let's go ahead and bump those up. I saw Bruce made a good comment in there about losing the 802.11b data rate. So that's obviously going to be on the 2.4 side. So let's start there. We'll bump that up to 12. And what about on the 5? We don't have to worry about B clients on the 5 gigahertz side. We're starting out at 6 megabits per second on the 5 gigahertz. Any recommendations from the audience there on the 5 gigahertz side? What are you guys usually using these days?
Yeah. What would you guys go ahead and use the chat function and let us know what's a minimum data rate that you would consider using in the 5 gigahertz band? What would you do as a minimum data rate? Salish says 24. Joshua says 18. Peter says 24. Dan says 12. Jared says 12. Alan says 12. Andrew says 24. It's just
24.
Yeah, but I'm seeing a lot of consensus here, though. It seems like that 12 to 24, somewhere in there, is kind of the sweet spot, isn't it?
Yep. All right. So I bumped it up to 12 on the 5 gigahertz side, and you can see it didn't change a whole lot. Let's bump it up one further. So that's the nice thing, is we can play around with different values here pretty quickly.
Turn it up to 11. Oh wait, that'd be down to 11.
All right, so now we've set our data rates at 12 and 24, between 2.4 and 5, and we can start to see, some improvements across the board. And these are, we're really going through all the low-hanging fruit at this point, right? So trying to see how we can, squeeze more airtime out of this really bad design is really what it comes down to. All right, so we've done our two low-hanging fruits so far, right? We've lowered the number of SSIDs. That bought us some more airtime. Then we've also increased the data rates, made our clients talk faster, which bought us a little bit more airtime, not a drastic amount. What's the next step that we could do?
The next thing, the next thing that we can do, you know what, Jerry? I think the next one that we had was number 4. I think I'm going to switch to. Oh no, what happened? I lost a slide. I totally lost a slide.
Oh man,
we're gonna
have to wing it.
We'll have to wing it, but we can do that. We're pretty good at winging it. So the next one that I had on the list, and I don't know if we should speak to this now, was to add more access points. However, I don't know if that's actually the next step that I would take on this specific design. Any comments?
Yeah. I would not. What does the audience say?
Yeah, what should we do to this design next? Oh, Nick nailed it. He says change the channel. Actually, no. Hang on. There's several here that are really good. Do you have eyes on the chat right now?
I do. Yeah. Change the channel plan is what I was thinking though. So let's start there. So yeah, let's go back over to our planning tab here. We've got our channel planner. So if we pull it up, you can see how I kind of have this really poorly configured right now. We've got 80 megahertz wide channels. I'm using just Uni 1 and Uni 3. So really we have a 2-channel plan on our 5 gigahertz band.
It's worse than 3. It's worse than 2.4.
Yeah, exactly. I like Evan's suggestion, remove 80 megahertz channel bonding. Maybe we kind of throttle down. So we start with 40, and you can see just by switching from 80 to 40, that opens up a lot more possibilities for me. So even without changing or adding any additional channels or unibands in the US regulatory domain here, we could just switch down to 40 and see, does that fix our problems, or what kind of positive impact will that make? Well, right there, we're already starting to see some prettier colors, right? And look at this area right here. So there's our drastic change, right? Coming up with an optimal channel plan. You can see we're already down to now 61% airtime utilization in this area to our 70% limit. So not great. We're still below that 70%, but we're not going to be able to do any kind of voice over Wi-Fi or anything in here. But yeah, you can see, it's definitely improving things drastically with that. Well, let's kind of continue down that. Since we saw that made a significant improvement, let's say, you know what, we can actually use some Uni 2 channels, some DFS channels. Maybe we can't use channel 140, 144 yet, but let's see if we can stick with these 40 megahertz wide channels, but add a bunch more channels to the mix and see what that does to our environment. That's looking a lot better. Now we're all the way down to 32% channel utilization, and almost 70% free. So we've basically completely flipped this around, right? From being well over 70% utilization to now having almost 70% airtime available on the channel.
Nice. Cool. So should we go back and look at the last point here, the best thing that we can do to improve this network?
Yeah, absolutely.
All right, sweet. I was stalling a little bit because I was actually doing a live edit of the slides. And so look at that. 4 is now changed to better channel plans. So computers are cool. 2018 is cool. So after we've implemented a better channel plan, what else can we do? Well, I think the last thing that we can do, at least for this design, is more. Oh, wait, hang on. I'm sorry. That's a mistake. Ignore that. Really, what I meant was just ignore that.
Worse. Your spelling is getting worse.
There's nothing to see there. But really, maybe we should think about better AP placement. So, Jerry, what can we do to this design with better AP placement? And really moving APs to improve airtime utilization? Are you serious?
Yeah, so this is, getting more into the drastic measures, right? You can see even just keeping, the APs where they're at, we can make a much better situation out of a bad design with some pretty decent configuration changes, right? But if we really need to optimize this, we're really going to need to get that, especially for critical things like voice over Wi-Fi. So let's introduce some voice applications into here. So I'm just going to change their smartphones.
Yeah. Oh, yeah. No, that works. I was going to say another way to do the exact same thing. It's all good.
Yeah, so we're going to add some voice to our network, which is going to increase our utilization. So you can see now our limit is 50%. So you can see here under our limit percent, it's changed from 70 to 50% because we've added some voice clients to the applications in our environment. So now you can see that's updated our threshold there. So some of the areas still looking pretty good, even with the channel changes and the AP placements. But if we want to further optimize this without, maybe we can't make any other changes to the configuration. But if we start moving our APs and then redo our channel plan one more time, we should be able to further optimize this. So that may be, a good next step is by starting to push some of these APs out of there. And I'm actually going to use our fancy new coverage planning feature to even do this faster, so we can see exactly where might be optimal spots to place these APs. And you know what? I would probably venture guess here that we could possibly even reduce the number of APs in this environment by placing these APs optimally.
Hang on. So you're telling me that less APs could equal better performance in the end?
I am, Joel. I am saying
no
that.
way. That can't be possible.
It's true. It's true. Believe it.
Wow. Crazy.
I
Yeah.
wouldn't lie to you.
Joel Fretz, and he has an excellent name, I might add, agrees with you and says that better AP placement would be moving APs out of the hallway and into the outer rooms.
So yeah, you get the idea. Something like this. Obviously, we need to make sure we've got a bathroom in the or an AP in the bathrooms, because that's where high utilization is.
And by the way, lots of awesome other tips have been coming into the chat, like Bruce is saying, well, hey, what about, transmit power? Maybe we could bring down transmit power a little bit to bring our coverage cells down a little bit, make smaller coverage cells. That would increase airtime utilization, or that would decrease airtime utilization because we would have smaller coverage cells. Let's see. One person suggests, maybe tweaking guard intervals, maybe trying to go for a short guard interval to increase data rates. That could help. That could help airtime utilization as well. So this certainly is not I would not say that this is I wouldn't say that our list is exhaustive here. Maybe some of the big things, but there's lots of other things that you can do.
Yeah.
One question that came up is what about channel bonding? Well, here's the thing about channel bonding. That is, using a wider channel, whether it's a 40 megahertz channel or an 80 megahertz channel, that will net you a faster data rate inside that coverage cell. But remember that once we get more than, 12 APs used, then we start to run out of channels to be able to use. Yep. And so it's important to, in some cases, really in a high density network, you really are going to come back down to a 20 megahertz channel in the end. My rule is 20s by default, 40s if you can. That's kind of my rule of thumb. I don't know, Jerry, what do you think of that?
I always use Keith Parsons' rule of thumb that stuck with me was use the widest channel that you can while avoiding co-channel interference. So as soon as you start to introduce co-channel interference, then you need to back off on your channel widths. Typically more channel widths are better. There's a few caveats with it of it takes more energy to transmit on a wider channel. So if battery life and battery consumption is a concern, you could be eating away at your client's battery life slightly. There's some benefits. There's some additional benefits besides co-channel interference to a narrower channel. Most of the time, from an AP's point of view, it's not going to make a difference from a power consumption standpoint, whether you're doing 20 or 40. It has enough power to back that up.
Just remember that we started out with the ultimate channel bonding. We started out with 80 megahertz channels, and there were not enough channels available for a proper reuse plan. And so, bring it back down to 40s, and in some environments, you may need to bring it back down to 20s in the end.
Yep. So I would have to play around with this a bit more. It looks like in these high density areas, so the areas in red I set up as very high density. These are going to need some additional APs, either in these areas or around these areas. And then probably what I could do is reduce the number of APs. I pushed all the APs from the hallways towards the exterior of the building. I think I would stagger some of those out a little bit more if I were to, pay a little more attention to what I was doing there. And I could have utilized the same number of APs, but now you can see after adding a couple of additional APs into those higher density areas, we can reduce that airtime altogether.
Seems like that'd be a good environment for maybe some directional antennas or something like that to chop up those coverage cells into smaller pieces, something like that.
Yeah, and that's another, kind of direction that you can go with some of this besides just moving the APs. Maybe moving the APs isn't an option, but then you're looking at directing that signal another way, or steering that signal another way by using some type of directional antenna.
It's pretty cool to be able to look at this map and see exactly, not exactly, but, have a model of where the problem areas can be and where we're not going to have problems,
Yep.
I really like that. So cool. Well, let's do a quick review of kind of the steps that at least Jerry and I went through. And I think, based on what I'm seeing in the chat and stuff, there's a lot of other options, lots of other ways you can decrease airtime utilization, but these are kind of the ones that Jerry and I boiled things down to. So one is, remove non-Wi-Fi interference. That might also mean, having a frequency use policy or a spectrum use policy where you decide, okay, we're going to allow this device to just consume Wi-Fi channel 120. And so, any non-Wi-Fi devices need to be in this slice of spectrum or something like that. So it's not even so much removing non-Wi-Fi interference. It's thinking about how can we plan everything around each other and make it all happily coexist in the same space. Lowering the number of virtual SSIDs is a big one. I've seen lots of environments where, you have 10 virtual SSIDs because whoever built the network just didn't understand that would add additional management overhead. So try reducing your number of SSIDs. Prune off those slower data rates. If you can drop all of the 802.11 and 802.11b data rates, that's 1, 2, 5.5, and 11 megabits per second, drop those off. Consider in higher density environments, configuring your minimum data rate to, I would say, either 12 or 24 megabits per second. Cut everything off below those data rates and force everything to talk faster. Implement a better channel plan. Make sure that you're properly reusing your channels. And that might mean backing off. That would usually mean backing off from an 80 megahertz channel down to a 40 and maybe even down to a 20 megahertz channel plan, depending on how much spectrum you have available, how many neighbors you have, how many APs you have, how well RF propagates. There's a lot of different things that play into that. But remember that a wider channel is not always better. It will net you more speed inside that individual coverage cell, but you might run out of channels to reuse. And then, of course, don't forget better AP placement. If you've got all of your APs in the hallways where they can all hear each other perfectly, but can't hear the clients in the rooms, so we get lower data rates and all that, try moving your APs to where the clients are. Move them out of the hallways and make sure that those APs can't hear each other as well. Make sure that they can focus on hearing the clients better, and that should net you faster data rates in the end. So lots and lots of other things that we could talk about as far as how to improve airtime utilization. It's a very fun topic. I don't know, Jerry, any additional comments before we jump into Q&A?
Yeah, I think Seth made a good point about adding to that list, kind of along with the better channel plan, a power plan, right? So a transmit power plan from the AP side can have also a significant impact. So I would say I would do that prior to taking the drastic measures of number 5 of moving APs, adding APs, changing out antennas. Those are the things that get really costly and time consuming. So another good low hanging fruit one would be, possibly coming up with a better transmit power plan.
Yeah, absolutely. Any other ones you can think of to add to the list, or do we call it good there?
I mean, I think I'm sure there's plenty of other, there's been a lot of great tips and stuff in here. Yeah, I think that covers the major ones to start with, at least.
The big ones. Awesome. Great. Cool.
I think the only other thing I would add to it is really at the core, how to reduce and improve airtime utilization is get the clients talking faster to get them on and off the medium quicker. And how do we do that? One of the main ways we do that is moving or placing the APs where the clients are, right? So if we're placing the APs in the hallways or, a good distance, through multiple walls of the client, that automatically tells us that client is going to consume more airtime, or the AP is going to consume more airtime to talk to the client. Retries are going to be higher. So at the core, and as a summary, is we need to figure out how to get the clients on and off the medium as fast as possible. Which ties into SNR and everything, which is getting the clients closer to the APs.
Yeah, absolutely. Cool. Well, let's go ahead and move towards Q&A. Before we do that, I just kind of want to give you guys the opportunity for some next steps. If you want to learn more about Ekahau, if you want to spend some time with us one-on-one, I would highly recommend getting in touch with one of our sales engineers, aka technical solutions architects. Whether that is Nick Turner over in the UK. Unfortunately, Nick couldn't be with us on the call here because it's late at night or something like that over there. Nick is absolutely fantastic. Can't recommend it enough. And then also, I'm extremely excited to welcome Clayton Matthews to our team. Clayton joined our team a few weeks ago now, but he is no stranger to Ekahau. He used it extensively at one of his previous companies, and even championed getting his company moved over to Ekahau, which I think is pretty awesome. So we're extremely glad to have Clayton on board. Welcome, Clayton. So can't recommend these guys enough. Feel free to get in touch with them if you want to get a one-on-one demo of Ekahau Site Survey and the Sidekick and all the stuff that we showed you guys today. So with that, I think it's time to move into some Q&A. So I don't know, Jerry, you want me to read off some questions or something, and we can just kind of go through these?
Yeah, we're only 10 minutes over, I think, our scheduled time for today, but that seems to be a reoccurring thing. I think we just need to start making these things an hour long. But
yeah, let's give up.
Yeah, let's go ahead and start pounding through as many of these as we can here. So yeah, the first question that is asked is about what kind of 802.11 packets are used to measure airtime utilization.
Ooh, that's a good question.
Yeah, and I'm trying to think of what lens that question is kind of coming at us. So is that coming from the simulation airtime utilization that we were looking at, or in general, what makes up airtime utilization?
Yeah. So to that attendee, and their name is anonymous, so I can't reference them directly. One thing I'd recommend doing is go check out our previous webinar on this topic. We dive in, if you haven't seen it already, we dive into the nuts and bolts of what is airtime and how do we determine what airtime usage is. But Jerry, maybe you'd like to speak to in Ekahau how we do those calculations a little bit. I don't know. Do you think that kind of plays into this question a bit?
Yeah, so the way that it is calculated is, really any 802.11 frame that is, from a measurement standpoint, any 802.11 frame that is, decoded is able to be determined as airtime utilization. And then that reserves the medium for an amount of time, right? Every time a frame is transmitted. So we can use that to determine airtime utilization. Same in Ekahau, we can simulate that by defining the clients, the type of clients, figuring out, and simulating what their data rates are going to be based on the number of spatial streams and channel width and those kinds of things. And then based on all of that, we can do a lot of math behind the scenes to simulate what airtime is going to be consumed from each of those clients that we're defining in a given area of the building. And based on there's a lot of moving parts, right? So we're going to simulate what AP that client is going to be associated based on where that AP is located and where that client is being defined in the building. And that's tied in with the areas that we're specifying in Ekahau. And then based on all of those different requirements, we can come up with a number of how much time it's going to take for that client to transmit its frames.
Awesome. Great. Another good question is, can you customize the spectrum utilization screen to exclude channels since, for example, the channel showing high utilization could not be used in the UK anyway, so that it wouldn't be showing a false positive? I think I can answer that one. Eric, in Ekahau, you can tell Ekahau to only map a specific channel on the display. So Jerry, I think you're going to show that.
Yeah, better than talking about it. Let's show it.
Show it, yeah.
All right, so I'm going to get rid of my bad airtime project here. And let's go back to that one that we were looking at before. So this is the one we looked at initially. Let's look at spectrum utilization. And yeah, under your visual options, you can to some extent. So we can go under options here and we can specify by default it's showing the maximum over all channels that are being scanned. But if we want to look at a specific channel, we can do that. So we can't probably get into the level of detail that maybe you're looking at of excluding and kind of plucking out certain channels, but we can isolate it and look at only a certain channel. So we can start out by looking at all the channels and then from there, filter down to a specific channel. So for example, if I see here, hey, this is a channel that I care about. So this was on channel 1. Let's see, why is this tooltip not coming up? Let me move my mouse back over here.
Because you're trying to demo something, that's why.
149, yeah. It's getting camera shy, you know. All right, so 149 is what we want. So now I'm looking at just channel 149. So this is the utilization across the entire surveyed area for just channel 149. For example, if I move my mouse over here now, you can see, yeah, this is only showing spectrum utilization for channel 149. So not maybe exactly what you're looking for. I can certainly pass it along as a feature request if you want to be able to pluck out certain channels, but hopefully that at least gets you what you need for now.
Awesome. Thanks, Jerry. Cool. So the next one is, let's see here, just combing through all the questions here. A question from an anonymous attendee is, how do we approach improving Wi-Fi in high density areas such as dorms or hotel settings? The volume of rogue devices and living space items that transmit is a nightmare. So how do we approach improving Wi-Fi in high density areas such as dorms and hotels? You know, I think that a big part of that, you know, is of course try to get the APs into the rooms. You know, really try to do that. I see a lot of hotel and dorm deployments where they're in the hallways. Get those APs closer to the clients. Implement a good channel plan. Implement a good transmit power plan. Prune off legacy data rates. Things like that. Just try to decrease airtime utilization as much as possible. And so basically all the tips that we showed you today, you asked this question very early on in the webinar, but all those tips, they should play into that very heavily for helping you improve airtime utilization. So question from Alex, when you prune off slower speed devices, or slower data rates, do they still show up as non-Wi-Fi devices or take up some airtime? Good question, Alex. Basically, when we prune off lower data rates, let's say that we prune off data rates 1 through 11, so 1, 2, 5.5, and 11, that will disallow 802.11b devices from associating to the network. They will not be able to associate to the wireless network. The only airtime that they will consume going forward is their probe requests asking who is there. They'll ask who is there, and they won't hear an answer that they can decode. And so that's basically all that's going to happen. It will improve airtime utilization because now you don't have that slow legacy device hanging out on your network. So I would guarantee that if you disable legacy data rates on your network, then you know, that one guy that's still using a Palm Trio is going to show up at your office the next day asking why his Palm Trio doesn't connect to the Wi-Fi anymore. So that's I think that's I think that's all I have to say about that one. Similar question from Brian. Is it true that clients can still transmit at lower data rates even if you disable legacy 802.11b data rates due to client proximity? Is my understanding that this only affects time of association. Can you comment on this? Yeah, Brian, like kind of similar to what I said a moment ago in that last answer, when you disable legacy data rates or when you disable legacy protection mechanisms, 802.11b clients will no longer be able to join the network. They simply will not be able to associate to the network. In fact, when the client, when you try to look at the list of available networks, since your beacons are going to be transmitted at a higher data rate, like 12 megabits per second, the 802.11b client won't even see the network anymore because it literally cannot even decode that beacon, and so it will not even see the network at all. Will not be able to associate. I don't know. Any comments on that, Jerry? Before we move on to the next one.
No, I think you did well with it.
Awesome. Question from Jim: is there a difference between a virtual SSID and one that is not virtual? No, not really, Jim. They're basically the same thing. Virtual SSIDs are extremely common at this point. You've got an SSID that's being broadcast by an access point, and then a virtual SSID is simply when the AP will broadcast two SSIDs. Just keep in mind that every virtual SSID that you add, it adds its own management overhead. Andrew Von Naj wrote an awesome blog article about this, complete with a calculator. At is it revolutionwifi.com or something like that?
I think that'll take you there, otherwise .net.
Yeah, is it? Yeah, revolutionwifi.com, revolutionwifi.net. Just go check the intertubes and see what you can find out there, but Revolution Wi-Fi is that. Jerry, do you see any questions there that you want to tackle?
Yeah, let me actually share a quick screenshot here of there was a question around, Let me pull it up actually again. What was the question? Do you have any false positive radar detection sample video? No video at this point, but that is something that we're working on adding a feature to the, if you haven't seen yet, we've introduced a beta interference detection feature. And we have captured some, at least kind of still images here, just to kind of show you that it can be detected within Echo as far as like a weather radar type thing, right? So I don't know if this is what you're kind of after, but this is what it would look like on the spectrum here.
Oh my gosh, how did you guys get that? That's awesome.
No comment. No comment.
No comment. All right, we can neither confirm nor deny, huh? Nice, nice.
So
cool.
Yeah, you can with the Sidekick and the speed of the spectrum analyzer and the detail and the resolution potentially capture some of those. Now the difficult part about it, from my understanding about specific about like false positives, is this going to be vendor independent or vendor specific, right? Where certain vendors and even certain models within a vendor running certain firmware, may see these kind of false positives. So it's all subjective to those kind of things. So just kind of keep that in mind, but we can detect these kind of events potentially in this near future with at least the signature detection capabilities.
Nice. Looking forward to that. Love how you guys are always working on this and just making it even better and better and cooler. So let's see. A question from Peter is, for measured APs, I expect the conditions would change depending on the time of the survey. Therefore, are airtime utilization charts useful in site survey reports in contrast to predictive plans, or should these snapshots only be used for troubleshooting? Peter, that is an excellent question, and definitely one of the caveats of Wi-Fi in general is that the environment is always changing. My recommendation is that if you want to include a spectrum utilization value in your final reports when you're done with a survey, I would try to take the survey at a peak network time when people are using it. Sometimes that does mean that you need to fight through crowds of people while doing the survey, which can be tricky. But that would be my recommendation, is try to survey at a peak usage time, and just make sure that your customer or your manager or whoever it is that you're giving this report to understands that that is a snapshot. That is a snapshot of what happened. Over on the predictive side, what Jerry modeled is basically, when the network is at load, when the network is at capacity, what will things look like? It's almost kind of a worst case scenario kind of thing, where we're like, okay, if the network is being used at the capacity that we're designing it for, what is our prediction of what airtime utilization is going to look like? So just being sure that you convey that understanding of that it was a snapshot, or that it was that it is a simulation to your customers, I think is a good idea. Let's see. God, I think I'm looking at, we've got a couple more questions.
Take maybe two more questions, and then we'll let everybody go here. I know we're already well over, but obviously this is a good topic.
We've just got so many great questions here that it's hard to leave them behind.
Here's one I can answer. If I wanted to view this presentation again, where can I go to access it?
Oh, that's a great question.
I think I can handle that one.
Go for it.
So we are recording this session, and same with the previous one. So these will be published to our YouTube channel as well as on our recordings on our website. So you can go ahead and check those out. Obviously, if you're here, you've registered for it, so you should get an email with a link to that recording, typically within about 24 hours.
Yeah, absolutely. And so the website that you can go to find these recordings is in fact www.ekahau.com. And if you go to training and click on webinars, you basically can see every single webinar that we've ever done, including the last one that we did. And here's where we discussed airtime visualization, or visualizing airtime utilization last time. So you can go find that very easily on our website, ekahau.com/training/webinars, if you want to just type something in and go right there. Okay, so I think we've got time for just one more question. A good question from Joshua is, any quick and dirty ways to help model and detect multipath issues? Joshua, I can't think of a way to model that, but you know what I'm looking for? If I'm worried about multipath issues, a big way that I'm going to troubleshoot that is I'm going to look at the retry rate. I'm going to take a packet capture and look at overall how many retries we saw in that environment. And if I see tons of retries, maybe north of 25% or something like that, that's probably when then I'm going to start worrying that I may have a multipath issue. And in that case, I think the first stab that I would take at that is I would try turning off the short guard interval and reverting back to a long guard interval and see if that helps. Having good client devices that support multiple spatial streams, I think, will probably help as well. I think that's going to give them some more ears to be able to decode that stuff a little bit better. Although that's getting into some pretty theoretical stuff that I don't totally understand, to be honest. So, Jerry, any comments?
I mean, yeah, I think you're on the right track. I mean, I think, yeah, it can be difficult to detect these kind of destructive multipath issues. Most of the time, though, depending on the environment, I mean, I've seen some environments where you can have some pretty destructive multipath still, but most of the environments, because of multiple spatial streams on the APs and on a good majority of our clients, it's a non-issue, right? That we don't really see a lot of destructive multipath anymore. But yeah, if you're using older devices that are single spatial stream and those devices are having problems where your other newer devices that are two spatial streams are not having problems, that right there could be a good sign, good indication that it's a multipath issue. And, there may not be a whole lot you can do to improve it depending on the environment, other than upgrading the devices. One option may be to directional antennas, is at least in the past of one thing that we could do to help with multipath issues is, to avoid those reflections, steer that signal exactly where we need it, not have it bouncing all around the room in 360 degrees.
I love that you make the differentiation between multipath and destructive multipath, because I think back in the day, back in the 802.11g and B and A days, I think that multipath was always a bad thing. But then MIMO came along and kind of harnessed it and used it for good. And so now you kind of want a little bit of multipath so that those spatial streams can do their things. And that's when Wi-Fi just turns into magic. And
and that's what I'm saying. Like, really your best solution is to, if you have a multipath issue, usually it's the clients that are the problem, right? That they don't handle that multipath well, where if you have newer clients, it's actually a positive thing. So those clients are, newer clients that are, 2 or 3 spatial streams are going to typically perform even better in that environment, because of the multipath.
And watch me tie this all back together as we end the webinar, so it's all seamless and cool. When you upgrade to newer client devices, perhaps with more spatial streams, that's going to allow them to get on the air quicker, get off the air quicker by using a faster data rate, and by hopefully receiving data correctly the first time, so that a retry is not required, thus lowering utilization on all their channels. So boom, tied it all back together right there.
Perfect. All right. Well, thank you everyone for attending today's webinar. If you have any other questions that we didn't get answered, please contact Joel or myself. We'll be happy to take those offline with you. We will be sending out, as I mentioned, a follow-up email, typically within 24 to 48 hours, with a link to the recording of today's webinar. But yeah, on behalf of Akahau, I just want to thank everybody for joining. Thank Joel for putting this presentation together and knocking it out of the park.
I didn't do anything, Jerry.
Yeah, you whipped it all together. You really put those bullet points on those slides well.
Well, thanks for handling all the demos and stuff. They were awesome.
Yeah, I enjoyed it. Thanks, guys. Thanks everybody for attending.